Okay, you guys, so now what we're going to do is we're going to talk about how we can apply everything we've been working on with the normal curve. We've been working on the mean is 0, the z-score is 2.3. Find the area above that. You know, we've been doing all these kinds of problems, right? But now, how can they get applied? Like, what is the purpose of learning these? All right, and that's the big deal. And this is where the transfer comes in. It's such an important concept for us. So what we're going to do is we're going to take our z-score. Now, we've been just being told z equals negative 5.6 or z equals 1.13. Today, we're going to figure out how do you get that z-score? Where does it come from? And we had actually done this when we did chapter 3. Now we're going to put it all together with the area of the curve. So you've got your z-score formula here. All right, and we want to be able to, our objective is we want to be able to find the probabilities for a normally distributed variable by transforming it into a standard z-score. So for number 12, the mean number of hours an American worker spends on the computer is 3 hours per workday. Assume the standard deviation is 0.5 hour. We want to find the percentage of workers or the probability of workers, okay, because remember the area inside the curve can be a percent, the percent of the people or the items, or the probability of an item being in that range. So we want to find the percentage of workers who spend less than 3.5 hours on the computer. And this is important. We need to assume that the variable is normally distributed, because if we don't know that it's normal, then we can't use the normal curve. All right, so we know that in order to find the z-score, we need an x value, we need a mu, and we need a standard deviation. So let's get those pieces first. We need our x, we need our mu, and we need our standard deviation. So if we go back to the problem, we're told in the first sentence the mean number of hours is 3.1. And the standard deviation is 0.5 of an hour. Okay, we want to find the percentage of workers who spend less than 3.5 hours on the computer. So we could actually change this to be less than 3.5. Now, when we have a z-score, we have a mean of 0 and a standard deviation of 1, which means that in the middle, the mean is 0. And that's what we've been doing over and over and over again. We are eventually going to transfer these numbers into a z-score. But if you think about the normal curve, right now our mean isn't 0. Right now our mean is 3.1. Okay, because the mean goes in the middle. And 3.5, in relationship to 3.1, 3.5 is higher. And we still need to use the same idea. Which way are we shading? We're shading to the left because it's saying find the percentage of workers who spend less than 3.5. Now, on your chart, you have to be really careful because yes, on your green chart, there is a 3.5, but that's if the z-score is 3.5. This z-score is not 3.5 because in order to have a z-score, you need a mean of 0. So what we need to do, first we drew our picture. Second, we're going to do the z-score formula. Z equals x minus mu over sigma. So our x is 3.5, our mu is 3.1, and our sigma is 0.5. All right, do control divide in your calculator to create a fraction. Put the stuff up top, the stuff in the bottom. We get a z-score of 0.80, which means what we've done is we've transformed, remember our objective, we're going to transform the numbers from the problem, bring them to the z-score scale, which means a mean of 0 and our z-score is 0.80. So it's almost like we got rid of these. I don't want to cross them off, but it's almost like we got rid of those numbers and brought them down to the z-score scale. So now, is that our answer? No, because we still need to look up the area. Whenever you deal with a normal curve, if you do a problem and you don't use this chart, you did something wrong, okay? It's a great checks and balances. we have a positive z-score. So we're going to go to positive on the second page. We've got 0.8 and 0.00. So this is our answer. This is the area, 0.7881. And since that table matches the shading here, then our third step, our area equals 0.7881, or we could say 78.81% of workers spend less than 3.5 hours on the computer. Okay, so let's do the next one. Each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Right. Assume that the standard deviation is 2 pounds and the variable is approximately normally distributed. If a household is selected at random, find the probability of its generating more than 30.2 pounds per month. So, right now, just from the problem, we are told that the mean or the average is 28 and that the standard deviation is 2. Okay, so as we draw our curve, we know that what is going to go in the middle? A mean of 28. And 30.2 is located to the right of that. Think about where you're going to shade. More than 30.2 means you're going to shade here. Okay, so if we're shading to the right of this more than 30.2, now what we're going to do is we're going to do our z-score. Z equals x minus mu over sigma. And when you plug this in your calculator, you get 1.10. So that's our z-score. It's a positive z-score. So we're going to look it up on the positive table. Okay, 1.1 and 0.00 gets us right here, 0.8643. But we need to be careful because 0.8643 is this shading, which means it's here, 0.8643, like we've been practicing. So to find the area, the shaded area, right, if you want to call it shaded area, we're going to do 1 minus 0.8643, which will leave us with 0.1357. All right, remember, we've talked about this in class as well, I'm sure. At this point, you have to label as you go, guys. This is a complete answer with this diagram all labeled up. Z equals, put in your work. Shaded area equals, put in your work. Like, look back here. If you didn't write Z equals, it would be easy to make the mistake of circling this as your answer. But for these problems, your z-score isn't your answer, your area is, all right? Which means we have a 0.1357 probability. You could have also written it as a 13.57% chance that a household makes more than 30.2 pounds per month of garbage, newspaper garbage. Now, B, all right? Try to set it up on your own, okay? Pause the video, see how far you get. Use pencil, you can always erase, right? You're going to draw your curve. Mean goes in the middle, 28. 27 is lower than that. 31 is higher than that. And we want between those two. All right? Which means that we have two z-scores we need to find this time. Right? We have this z-score, z1, and this z-score, z2. So when I do z1, it's 27 minus 28 over 2, which gives us negative 0.5. And then z2 is equal to 31 minus 28 over 2, which is 3/2, which is 1.50. Now, a couple notes that you need to make for yourselves, all right? The first note is z-scores always round to 2 decimal places. And you need to look, if it's something that continues, I'll show you a couple examples, but if it's got more decimals, which you will definitely see those, you need to look at the third number to see if the second is supposed to round. If you don't round properly, you're going to look up the wrong number in the chart, and then your answer's wrong. Okay? The second thing is that area is always 4 decimal places. That's exactly what we get out of the table. We're not like shortening those answers at all, okay? The third note you need to make is right here. We never subtract z-scores. We have to look, we did this on in the first section of the notes as well. We always look up both of these areas and then we subtract the areas from each other. So when we look up negative 0.50 on the table, okay, that's on the front, you should be getting 0.3085, that goes here. And when you look up positive 1.50 on the second page of the table, that's this area for the second z-score, and that is 0.9332. So for our shaded area, we're going to get 0.9332 minus 0.3085, which should give us an answer of 0.6247. All right, so to the next page. We're actually going to hold off on number 14. There's just something slightly different about it that I'd like to just chat with you guys about in class, okay? So number 15, now is where I'd like you guys to go through and do these together, like do this, all right? This is applying everything that we just did. So yes, I know you could just keep playing the video and watch me do them, but it's also incredibly important that you try them on your own so you know what kind of questions and pieces you don't understand when we have our next class together, all right? So it is known that the heights of American adult women are normally distributed with a mean of 64 inches and a standard deviation of 63. Remember, 5 feet tall is 60 inches. All right, so we want to first find the probability of a randomly selected American adult woman being shorter than 5'3", which means 63 inches. Okay, so we want shorter than 63. So you're going to have your curve, right? The mean is 64. Standard deviation equal to 3. We want shorter than 63 inches, so we've got this here. All right. Z equals x minus mu over sigma, which is negative 1/3. So this is that spot that I was telling you about. This one is negative 0.3 repeating. So we would have negative 0.33 and stop because z-scores round to 2 decimal places. When you look up this one, the area you see is exactly the area that we want because it's matching the shading on the first table. So we should get 0.3707, and that's actually our answer. Our shaded area, or our probability, is 0.3707. All right, for part B, taller than 5'9" is taller than 69 inches. So we're going to draw our curve. 64 in the middle, 69 over here. We want taller than that. So z equals x minus mu over sigma. Remember, guys, if it's a left z-score, it's going to be negative. The smaller number is going to be in the front. If it's to the right, it's a positive z-score, which means the bigger number is to the right. Okay, it's not like the mean is always the second thing that's being subtracted. This gives us 5/3, which is 1 2/3. And when you put this in your calculator, this is 1.6 repeating. So when you round that to 2 decimal places, it is 1.67. If you write 1.66, you're going to get a different answer than what I'm getting, okay? When you look up 1.67, the area that goes with that is 0.9525. So then our shaded area is 1 minus 0.9525, and we should be getting 0.0475. All right. If you are having trouble with the chart, it's really, you need to let me know, because we've spent a ton of time practicing. It's important, clearly you can see you have to use the chart. So if you need help, I'd love to help you. Come get an extra help session, okay? We can sit down and chat it out one-on-one, okay, or in a small group setting. So part C, 64, 61, 67, dun, 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 right? 5'1" is 61 inches, 5'7" will be 67 inches. So this is like the other example we had done with the garbage right here, B, okay? So when we're setting up this one, we're gonna do 2 z-scores. I'm gonna do my first z-score being 61 minus 64 over 3, which gives me negative 1.00, 67. So Z2 is going to be 67 minus 64 over 3, which is positive 1.00. When I look up these areas, when I look up negative 1.00, my area that goes here is 0.1587. And then my second area is 0.8413, which means that when I find my shaded area, or my probability of this occurring, we're going to have 0.8413 minus 0.1587, and we're going to get 0.6826, or there is a 68% chance, right, 68.26% chance that a randomly selected adult woman is going to be between 5'1" and 5'7". Good job today. Make sure you jot down whatever questions you have so that you know to ask them next lesson.